All right, when everything moves together, all right, that's called heaving, and it moves the whole object. Whenever it moves in the middle, and so part of the underside stays in one place, that's called adheaving or adfreezing. And these are just the different things that causes buildings to go upwards. Heaving is up, settlement is down. Same thing if we're dealing with piers. So we dug those out and we pour concrete in there. If the whole thing is moving, then it's adheaving. I'm sorry, if the whole thing is moving, it's heaving. If only part of it is moving, then it's adheaving. All right. And then if, again, the whole thing is moving, it's heaving. All right. This I've only seen one time. So we had a beam pocket, and it just so happened to see a steel beam too. And then the earth, or whatever, was pushing that wall inwards. And I think it was next to a parking lot. This was a commercial building. And so the whole foundation just started pushing in, and that beam is now sticking out of there. All right. As much as that beam was doing, and then whatever gap was there originally, that's how much that foundation has moved. Far more than 1/3 of whatever its width was. And we considered it serious. And I didn't want to have anything to do with it. I just said my opinion. They asked for it. I told them, yes, I think this is serious. You need to get a foundation repair company out here. If you're looking to say that this is okay, it won't be me. If you want to get a structural engineer, go ahead. That would be your cheapest way. But that would be their choice. All right. I can't do it. I'm not going to own this, or it's not going to be based on my words saying that it's okay. We may mention about excessive brick overhang. And again, we want to remember that 1/3 of its width is acceptable. And anything more than that is past our tipping point with the dominoes. This drawing here, this talks about cracks in foundation. Now, this particular crack that I'm looking at, I'm going to photograph it. It's going in my report, all right? And I'm going to take ownership of this one as it exists here today and say this is really no big deal. You're going to find this is a window down on the bottom here, and you can't really tell because it's so small in this drawing. And then this is above grade, and obviously we can see our floor joists and everything running up there. You're going to find that these 90-degree corner spots around windows and doors, you're going to see a lot of cracks that start right in that area. The bottom line is when concrete dries, or the proper term is cures, it shrinks. It gets smaller. So what's happening is concrete is shrinking and going up this way, and it's shrinking and going this way. And that 90-degree corner right here, that's my weak point. And when that happens, you're going to get a separation crack right in here. Now, there's no water stains in there. And most cracks, that's my biggest concern, is water seepage coming into the house. And that would probably be everybody's biggest complaint that they would get on this. But that would be my number one concern, is the cracking and the water seepage coming in there. I would not recommend this be repaired. I would not recommend that you do any injected epoxy, you do nothing with it whatsoever. However, things may change, and I will prep my client for that. If we do start seeing water seepage, or it gets wider or changes, then action might need to be taken. So it can definitely be a problem down the road. All right. Here we have another small crack, less than 1/4 of an inch, but you can see the different water stains. More so on the bottom those stains are, and then less and less as we go up. But you can see how dark and intense everything is on the bottom. This one I'm going to prep my client. Water did come in there. I consider this an active water leak. And I'm going to tell my client that they should get injected epoxy. It's not bigger than they, or not 1/4 inch or bigger. It's not two-directional movement. It hasn't been repaired yet. So we don't know if it's coming back on the crack. So it doesn't fall into the other list of items that we had up in there. So I don't think it's a structural concern, but I definitely would stop the water seepage from coming in. Typical water seepage repairs is what we refer to as injected epoxy. And the first thing they're going to do is take these little funnels or cups in here and tubes, and they're going to schmooey the epoxy. And let me take that back. Beforehand, they may even gouge out that crack and make it wider so that it's easier for the epoxy to get through the crack and get to the outside. After they do that, they're going to put these little cups on here and schmooey the epoxy over the top of that. And they'll do each one of these things roughly every 6, 9, 12 inches apart and work their way up the crack. They'll let that cure, let that harden, and then they're going to schmooey over the top of the crack and in between here another coat of this, so they're going to seal the top or the inside of the injected epoxy. All right. Now that may be enough and that may work. All right. But truthfully, the best repair you can do is try and get that epoxy through and through the concrete and have it come out the other side. So we're filling in all these gaps and openings and widening it up on the other side. And then we're kind of gluing this concrete together. Not kind of, we are gluing or epoxying this concrete back together again. So what you do there, and after all this is dried, you start at this bottom one, and they're going to get a pump that's going to put that epoxy mix in there, and they're going to place it under pressure, and they're going to force it into that crack. And they're going to keep pumping it in and pumping it in and pumping it in until, sorry, I dropped my stuff. They're going to keep pumping that in there until all of a sudden it starts coming out of the hole above it. All right. So once it starts coming out of this hole here, then we're going to put a cap on this bottom one so it doesn't leak out anymore. And then we're going to put our pump onto this one. Again, pump that in there and keep pumping it until it comes out of this one. And so forth, and do the same process until it comes all the way up. Now the caps are only put on there when the slurry is wet so it doesn't leak back out. Once all this stuff dries, then those caps can be removed. There's no reason to keep them on there anymore, but that usually takes a day or 3, or maybe longer, I really don't know, nor do I care, to dry and be solidified. All right. So if somebody wants to finish this basement, they can just cut those off, and if it gets in the way, they can leave them alone too. It just doesn't matter. All right. So inside fire damage rods, cable steel. This no foundation one is something that happens quite a bit. You know, somebody has a patio or a slab, a floating slab outside, no foundation, no footing, not even a monolithic pour. And then they want to put some sort of shade cover over the top. So they put a couple posts on the sides and they, you know, put up a lightweight roof up there. And they're like, okay, this is enjoyable, but now the bugs are bothering me. So then they start putting some walls in there with screens. You know, this is great, but now I want to use this in the wintertime. So they put more walls up, and next thing we know, we just built a room on top of a patio slab. So keep your eyes open for that. Don't be fooled if that's the case. And if you don't know if it is or isn't, and one of the best things that I like to tell people is I don't know. You know, I don't know what kind of footing that I have underneath here. I don't know if this is acceptable or not. I don't know if somebody got permits and they put the, you know, they had it inspected during here. You know, all I know is I have a slab of concrete and they may have built on here, and then I'm going to look for signs of movement along the roof line as well. All right. So let's move on to the floor joist. Type, material, condition, safety concerns. You're going to see that's kind of relative that comes in there. So even though we have termites in our part of the country, they're not really all that big of a deal, I guess, when it comes in here. They're not as prominent as, I would say, like Louisiana and the southeastern states where it's very moist in the earth and they're closer to sea level there. But we do have them here. So, and it's not a common practice that we end up putting termite shields on there. Now, a termite shield would actually be a piece of metal that would go, I believe it goes underneath the sill seal. All right. So this is the inside of the house. This is the outside of the house. That piece of metal would go underneath here, underneath the sill seal, and you would actually see a piece of steel that exists. What about multiple small cracks and multiple walls? Again, as I kind of mentioned earlier when I was drawing on the picture, if it went up there, we add all those cracks together. That's our company's policy, all right? So if I have a bunch of cracks that are going in the same direction and they're all, let's say there's 5 of them, and they're all about 1/8 of an inch thick, that means that crack totally, or that foundation has moved 5/8 of an inch. 5/8 of an inch is over our 1/4 inch mark. We consider it serious, and we would refer that to a foundation repair specialist. And it's okay if people disagree with me, all right? Those, we set up policies, and those are our rules, and that's what we're going to be calling out. The company is ultimately responsible for the words of the inspector, and it's my goal now that we have other people working under this name, and of course I want the agreement of all my inspectors, but it's our goal to be consistent, all right? I don't want one person being lighter than on something than another. So going in there and saying the same thing is kind of important to us. So going back to the termite seal, and thank you, Mike, for that question. Piece of metal underneath the sill seal and it sticks out. And as long as we can see that, and the concrete is visible and it's not buried, termites have to come up the concrete, build a tube because they need to stay in wet area to get around the steel in order to get back up into the house again. At least it makes it noticeable where we're going to be able to see it, or the homeowner's going to be able to see it, and they could take action and get an exterminator out there. But because termites aren't as dangerous of an issue here in the Chicagoland area, it's not a common building practice, all right? But they are here, all right? You will run into homes with termite damage, and that termite damage can be severe. And and so putting termite shields on here is a cheap piece of metal that you would put underneath the sill seal. I really think it's a good idea, but it's not a common practice that we have. Because the top of the concrete is not going to be even, we're going to put some sort of styrofoam sill seal underneath here, and that's to pick up those minor imperfections and give me more of an airtight barrier there to keep drafts from coming through there. Then if we're on top of concrete, we're going to use treated lumber, and we're going to bolt that treated lumber into the concrete itself. So as the concrete's poured before it's dried, they're going to put these J-bolts in here. We want to make sure they stick up high enough to be able to put that sill plate on there as well. You'll find that the sill plates going over steel, they're not typically treated lumber. They're not required to be, so the only time they're treated lumber is when they're over the concrete. The numbers that are written up on the screen are going to be testable numbers. You should have those memorized. Anytime we start and stop one of these sill boards or sill plates going down, we need to have an anchor bolt within 12 inches there. Now, when they're putting the anchor bolts in there, they don't always know how long of boards they're going to be putting up there. So they may not be accurate. So typically it's going to be 12 inches from the corner, anywhere in that ballpark, and every 6 feet gapped after that. So 12 inches from the corner and every 6 feet from then on. You're going to find sometimes these are too short and there's no way to get a nut or a bolt on there. I've seen where people break them off and they fake them and put it on there. I actually found twice where I reached up there and grabbed it just because I heard somebody else tell me this story, and I pulled it off in my hand and it wasn't bolted in there. So, having it, checking it isn't a bad thing, and it's not a bad story to share with somebody what you're doing anyway. It might even give your client a little bit of warm fuzzy because nobody else would ever think to go ahead and check and make sure those things are secured, especially when it's easy, like in a garage or something like that, where you can actually get a good clear view of everything and make sure it's simple to see. Just give them a little movement, see if they're tight or not, all right? We talked about the treated lumber already, and again, look for wood rot, look for termite damage. Don't be afraid to get an awl or a long screwdriver, do some sort of probing. This is a little bit repetitive on here, but we're going to look for any sort of damage at all to the floor joist or to the sill plate itself. I also want to reiterate 1.5 inches to support a floor joist, 3 inches to support a beam or a girder, all right? Underneath the floor joist, and this particular drawing is really showing more of a balloon frame construction as opposed to our standard platform construction, so we're not stacking our lumber on this one. But sometimes we're going to get a foundation that is just really wackadoodle, all right? We shouldn't have any gaps. They should be filled in there. It should be straight, level, nothing going up and down. I am allowed to shim floor joist, all right? I would like you to know it's one shim only, and that shim has to be a material that's naturally resistant to rot, or plastic or steel, all right? If I go multiple shims because I need something more, then those have to be high density plastic or steel that needs to go in there. So if I put a shim in here to get this back up and level, if I can get by, when I'm talking about shim, I'm talking about those cedar 1/4 inch to zeros, all right? So if I need more than that 1/4 inch, I don't make 2-inch blocks of cedar wood and stick that in there. That's not what happens. That could be stacked with steel or plastic, that's fine, but not with the wood. So if I can get 1/4 inch in here to make everything perfectly level, that's a good thing. Anything more than that should be stacked in steel or high density plastic. And then these gaps in between here, that needs to be fixed with a grout or a slurry or a mortar, some sort of mix, so that we don't have that open and available for insects, termites, that water, everything else to enter the building.